Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our course, NFT Blockchain Decentralized App Development with Solidity and JavaScript. In this lecture, we are doing a course overview, talking about everything that we will learn in this course and the project that we will build. All right, so let's jump in. First, we will do a section on the Ethereum blockchain and smart contracts. We'll introduce what is a blockchain and a distributed ledger. We'll talk about Bitcoin and Ethereum. We will talk about Ethereum blockchain properties and do a deep dive into how Ethereum works. We'll also learn what is a smart contract and what is the Solidity programming language used to build smart contracts for the Ethereum blockchain. We'll also learn what is an NFT, a non-fungible token. Next, we'll do a JavaScript prerequisite section. For those of you who have never coded before, you will need to know how to code in JavaScript for this course. If you already have JavaScript coding experience, you can skip that prerequisite section. JavaScript is an object-oriented computer programming language. It's commonly used to make interactive effects on the web and much more. It's the #1 language for web development. After that, we will install Node and Npm. This will allow us to make a new Npm project, so we can install different packages very easily. And next, we will build a Truffle project. We will talk about what is Truffle Ethereum and how to build a new Truffle project. After that, we'll build an NFT smart contract with the Solidity programming language and the open Zeppelin contracts library. Solidity is a high-level programming language used to write smart contracts for the Ethereum blockchain. With Solidity, you can compile code for the Ethereum virtual machine. Solidity has a syntax that is very much like the syntax for JavaScript. Open Zeppelin is a series of tools for decentralized app development. There is a sub-library, Open Zeppelin Contracts, which is a library specifically for secure smart contract development. Open Zeppelin Contracts has implementations of token standards, so templates or standards of building a token like an NFT, a non-fungible token. As well, Open Zeppelin Contracts has many other features like reusable Solidity components where you can build custom contracts and even complex decentralized systems. After that, we are going to build a test for our NFT smart contract. Then we are going to deploy our smart contract with the Ganache personal blockchain. Don't worry if you don't understand all of the words and tools that we're talking about right now, because we're going to explain from scratch every single tool that we use and everything from something as simple as a blockchain all the way up to an NFT. Then we will learn how to test our NFT contract properties and how to build the functionality to mint a token. Minting an NFT means publishing a unique instance of your NFT token on the blockchain. This is how your digital token becomes part of the Ethereum blockchain. Minting an NFT is similar to how a metal coin is minted and added to circulation, like a dime. NFTs get minted once they are created. After that, we will have a prerequisite section on React because once we finish building our smart contract, we have to build the client side or the web application as part of our contract because we're building a decentralized web app. So we'll have a prerequisite section on how to use React, a popular library for web development, for those of you that have never worked with React before. Let's do a quick introduction to React. React is a JavaScript library for building user interfaces, what your website visitors see. It is fast, simple, and scalable. As well, React is open source and began in 2013 as an internal Facebook project. React is used for building browser and native mobile applications. You can build everything from a single page site or a server rendered application where you have client-server communication for things like a store or a multiplayer game. Who uses React? React is used by many companies like Facebook, its originator, Microsoft, Twitter, Uber, WhatsApp, Instagram, and many, many more. React is a very popular library. The benefits of using React is that it's much easier to build large applications, and you'll find that React is going to help us build our application quickly and be able to connect to our smart contracts. A wide variety of libraries are compatible with React, and React is supported on all major browsers and Internet Explorer 9 or higher. What coding language does React use? React uses either plain old JavaScript, known as vanilla JavaScript, or JSX, an extension of regular JavaScript. You can also use Babel, which allows you to use new ECMAScript 6 features, or just plain old JavaScript. We're also going to be using a library, React DOM, which is an extension of React. React DOM enables an efficient way to manage document object model elements of the web page. So just managing the different elements on your web page, like a button or a component or a container. React DOM is a package that provides DOM-specific methods. And React DOM can be used at the top level of a web app. After we have done our introduction to React, we're going to build the client front end for our decentralized website. We're going to build a Web3 application using Web3.js, another library. We'll talk about what is Web3.js, and we'll build our application and load Web3 in there. We'll also learn how we can run our project and use Metamask to load blockchain data and communicate to a wallet that has cryptocurrency in it. Then we are going to build a minting function on the client. So we will have a form that our client can use to mint a new NFT. And we'll be able to take the client request to mint the NFT and send it to our smart contract. Then the smart contract can send a response that the NFT was successfully minted. And we'll make sure that no one can mint the same token twice, because minting a token is creating a new NFT. And that is the course overview. I have taught many other courses on the blockchain here at Mammoth Interactive, like the Complete Python for Finance, the Complete Solidity Guide, Building Smart Contracts with Solidity, as well as Excel Machine Learning and Blockchain, the Cardano blockchain, and Blockchain Machine Learning. So feel free to check out those other courses. I'm very excited to take us through this new Mammoth Interactive course of learning how to build an NFT blockchain decentralized web application with Solidity and JavaScript. So join me coming up in our next lecture. We will talk about the few things that you will need to take this course. Hello everyone and welcome back to our course. In this lecture, we will talk about the few things that you will need to take this course. Starting off, you will need a terminal application, which is included by default on your computer. It's called the terminal on Mac or the command prompt on Windows. You can use any computer for this course, Mac, Windows, or Linux. We'll need the terminal application to create new projects, as well as install packages and run different scripts and deploy contracts and more. Next up, you will need JavaScript programming experience. Now, if you don't have experience, we have included for you a prerequisite section on beginners coding in JavaScript. So do watch that section if you've never coded in JavaScript before. As well, Solidity programming experience would be helpful but is not required. We will be building our smart contracts with the Solidity programming language. The syntax is very similar to JavaScript, so if you know JavaScript, you can quickly pick up Solidity. We do have a course and several courses at Mammoth Interactive about coding in Solidity, which you can watch if you want even more experience with Solidity. As well, HTML is helpful but not required. We will be using some HTML to build out some of the elements on our website. HTML is a markup language that allows you to build out your website structure and add in paragraphs and buttons and forms. So it's helpful if you have HTML experience, but if you don't, we will explain everything from scratch as we write the HTML. React web development experience is also required. There is a prerequisite section included in the middle of the course right before we start using React. Because first we'll be building out the smart contract, then we will be building out the front end client side, the actual web app. And so for that part of the course, we will be using the React JavaScript library to build out the website. So if you have never used React before, we have included a prerequisite section on React for you. As well, you will need a code editor. Visual Studio Code is the recommended code editor for this course. There is an optional Solidity extension that is free to install if you want to. Visual Studio Code is recommended because it allows you to have syntax highlighting for Solidity, and you can even compile Solidity and have your Solidity code tested right as you begin to type it. There are other code editors though, like just Visual Studio, Atom, and you can even just use a notepad or a text edit application. Just make sure the file is saved with the proper file extension, like .sol if it's Solidity, which you'll see in the course, and that there's no special formatting of characters if you are using something like a notepad. And there are many other code editors out there that you can choose. As well, for the later part of the course, you will need a browser that can use a Metamask extension. We're going to be using Metamask to test out our project, our web app. Metamask is a wallet that is just an extension in your web browser and also comes in mobile form. And what it allows you to do is it allows you to store your cryptocurrency. You can put in some dummy cryptocurrency just for testing. You can connect to dummy accounts for testing. So MetaMask is very useful. It's the #1 browser wallet, and it's supported currently by Edge, Brave, Firefox, and Chrome. We'll be using Firefox in this course, but you will need a browser, one of these, that can use MetaMask. It's just a free browser extension that you'll have to install, and we'll show you how later on when we get there. And eventually, MetaMask will support more browsers in the future. And that is all that you'll need to take the course. Before we leave, I'm going to give you some tips for debugging, because debugging is inevitable as a developer. So you will need some debugging tools throughout this course, because it's inevitable that you will come across some problem or some error message. If you get an error message, the first thing you should do is read the error message carefully wherever it appears. It might appear right in your code editor. It might appear in your terminal application, in your browser console or your developer console. So read the error message carefully, because it will often tell you exactly what is going wrong and where the problem is occurring. So if you can just solve the error message by doing what the error message is telling you to do. Otherwise, you can search up the error message or your question via a search engine. There are many answers on websites like Stack Overflow, which are built specifically for you to ask questions. You could even join a Discord or a Slack server and ask questions from other developers. I recommend joining a specific server like a blockchain or decentralized app development server, where you can ask other developers who are doing projects that are similar to your project. You can also visit the GitHub for whatever tool or library is not working, or visit the official website for whatever you are using that is not working. There may have been an update that you have to consider. Perhaps a tool has updated and now you have to write different code to achieve the same task. And as well, you could just revert back to an older version of a tool if you don't want to change up the code to fit a newer version of the tool. So you have a lot of options. That is what you will need to take this course. Join me coming up in our next section. We're going to begin our introduction to the Ethereum blockchain and smart contracts. Hello everyone and welcome back to our course. Before we build our Truffle project, let's discuss what is Truffle Ethereum. Truffle is for the smooth and seamless development of decentralized apps, also known as dApps or D-apps. With Truffle, you can deploy smart contracts, build web applications and websites, and run tests and more. You can compile and deploy their contracts and inject them into a web application. Therefore, it's helpful for building out the front end or the user-facing side for your decentralized app. You can build out smart contracts with Solidity, and then you can have an interface so that people can actually visit a website and use your service, whatever kind of decentralized app you have, whether you have a store or a voting system or a game. With Truffle abstracts away many Web3 and Ethereum complexities because it can be difficult to build a blockchain app, and Truffle really simplifies the process. Truffle is the most popular tool for blockchain application development. And that's an introduction to Truffle, so join me. Coming up next, we are going to build a Truffle project. So we'll learn how we can install Truffle with NPM and create a Truffle project within an NPM project. Hello everyone and welcome back to our course. In this lecture, we are going to be starting up our new Truffle project. We're going to be using Truffle to create our project, which consists of a Solidity contract to mint tokens with NFTs, and also a JavaScript front end. So the JavaScript actual site with HTML included. To get started, we will start a new Truffle project. So join me in your terminal application on Mac or your command prompt application on Windows, also commonly called the command line. This is an application included by default on your computer. And here is where we are going to create our project folder and as well install Truffle and start a new Truffle project. So I'm going to cd into my documents folder on my computer. Then I am going to create a new folder first to store my project with mkdir make directory. I'm going to call the project Hello Decentralized. Okay, then I'm going to hit enter to execute the command, and I'm going to cd into Hello Decentralized. Then can check where I am, and I can list out my contents with ls on Mac or dir on Windows. Now, currently we have nothing in the folder because we just created it. All right, now inside of this project folder, I want to start a new NPM project. So that way I can add packages with NPM. To start a new NPM project, you use the command npm init. Now, of course, you have to have NPM installed for this to work. Then you can hit enter through all of the metadata. And now if you list out your contents with ls or dir, you'll have a package.json file which consists of the metadata for the project. All right, next we're going to install Truffle. For that, we'll use npm again, and we'll use the command npm install Truffle. We're using version 5.4.11 in this course, and I recommend you use the same version because if you use a different version of Truffle, it can update and therefore have some changes. So you can try with a newer version, but if you find that there's some kind of difference or error, you may have to fix or change something in your newer Truffle version, or you can just use version 5.4.11. We're also going to save it in development mode. All right, then we'll hit enter and we'll wait a few minutes for Truffle to install. This can take a bit of time because Truffle is quite a big package. It also depends on a lot of other packages. So it's quite a large folder that is going to be added to our project. But it will be worth it, and then we can initialize our Truffle project. Great, and we have installed Truffle. Now, you'll likely get a lot of vulnerabilities, so just do npm audit fix as npm is prompting you to. This will address issues, and likely the vulnerabilities will go down. So let's run the command npm audit fix and allow some of the vulnerabilities to be fixed, which ones can, some of them cannot. And you don't have to worry about these for now. We can still build our project and have it running even if you do have some of these warning messages. You can fix these if you like, but this just is the nature of Truffle. Next, we can initiate a new Truffle project. So for that, I'm going to use my command npx truffle init. Now, we already used npm init to start a new npm project, and inside of that, we are creating a new Truffle project. This is going to use Truffle to actually create some files. And you can see npm, or here the console is giving you some hints on how to get started, like with creating a contract and creating a test for the contract. If you list out your contents of the folder now with ls or dir, then you can see we now have a lot more files. We have contracts, migrations, node modules, package lock, package, test, and truffle config. So let's take a look at these files. Here I've opened up my project folder, Hello Decentralized, in Visual Studio Code. Here I have my contracts folder first, which has a default contract, migrations.solidity, and this here is created by Truffle. So at the top we have the version of Solidity that the contract uses. So it can be compiled with a Solidity compiler that is greater than or equal to Solidity 0.4.22 and that is less than 0.9.0. Each time you create a Truffle project, this here Solidity version may change depending on how far in the future you are watching this tutorial. As of now, this is the Solidity version that can be used to compile this migrations contract created by Truffle. We'll also include the source files for you in this course if you want to just use the exact contracts that we used, because every time you do npx truffle init, you do get a new version of your project. But here, as long as your Solidity compiler falls in between this range, the contract will run. So we have our migrations contract, which has two fields, an owner and a last completed migration. We have a modifier restricted, which is going to say that a function is restricted to the owner of the contract. We also have one function set completed for when the migration is done. Now, inside of the project folder, when we used npx truffle init, we also got a migrations folder with one initial migration. So here we're requiring our Solidity contract, and we are calling the deployer to deploy the migrations contract. Then we have node modules. This contains all of the node modules that your project uses, and Truffle uses a lot of them. We have test, which is where we put any tests that we want. We can move that around. You have package lock, which is just a locked version of package. Package.json here tells you the metadata of your project, like the name, the version, which you can edit, any script that you want to easily run, an author, a license, and a development dependencies. Here we have Truffle as our first development dependencies. And if you list more dependencies here, then you can call npm install inside of the project folder to install all of the dependencies at once. Then we finally have truffle-config. This is similar to package.json, but it's the metadata for the Truffle project within our project of npm. So we have module.exports, and here we have networks, which we will configure in order for us to actually launch the development on some kind of Ethereum network. And we'll set that up later. We have networks, we have more data. All this is currently commented out, but you can comment it, or you can comment it back in. So you can remove these comments if you want to actually put back in one of these groups. You have Mocha options, compiler options for Solidity. So here we have the Solidity compiler version being used by this Truffle project. Okay, then we have a Truffle database, and all of this is optional except for networks when you want to actually run the project, which we'll look at later. So that is an overview of the Truffle project that we created. Coming up next, we're going to get started building out an NFT contract. So we will build a smart contract with Solidity for an NFT using the ERC 721 Token Standard, which is a standard template from Zeppelin for building an NFT contract. So join me in our next section. Hello everyone and welcome back to our course. Coming up next, we're going to learn how we can use the Open Zeppelin Nft Token Standard to build a custom NFT smart contract with Solidity. But first we need to know, what is an Nft Token Standard and why do we need it? We're going to be using Open Zeppelin contracts, a library with Nft Token Standards. Open Zeppelin is a library for secure smart contract development, and it has many sub-libraries like Open Zeppelin Contracts, which contains implementations of token standards, not just for NFTs, but for other token types as well. Open Zeppelin Contracts has other features like reusable Solidity components to build custom smart contracts and even complex decentralized systems. For more information on Open Zeppelin Contracts, go to the GitHub page for the library or go to the official website, openzeppelin.com, and the Contracts subpage. Now let's jump into Nft Token Standards. Instead of just building out an NFT completely from scratch, starting up the code for the smart contract, what developers have to do is use a standard, like a blueprint, to build the NFT token. Because if you build a token from scratch, it's going to be very hard for your token to be compatible with all of the decentralized exchanges out there and all of the web applications out there, because there are many of them and more are being created. So to ensure that your NFT can be sold and traded on many different platforms, we use a token standard, which is like a set of rules or a template that makes sure that your token will be compatible on all of these exchanges. And you definitely want your tokens to be compatible on different exchanges because you want your token to get out there. So with token standards, we ensure that our smart contracts and our NFTs remain composable. So when a new project issues a token, it remains compatible with decentralized exchanges. Let's talk about some popular token standards on the Ethereum blockchain, because there are many different types of tokens, not just NFTs. For example, there is FTs, or a fungible token. The ERC20 is the standard interface or the blueprint name for a fungible token. That is an interchangeable token. This would be something like a voting token, a staking token, or a virtual currency. There's another standard, ERC721. This is what we'll be using. This is a standard interface or a standard for non-fungible tokens, something like a collectible. There's also ERC777 to build extra functionality on top of tokens like improved privacy of transactions, and there are many more standards out there. Feel free to explore more on the official websites for different standards, like the official website for Ethereum and Open Zeppelin. The Nft Token Standard is 721, ERC 721, and ERC stands for Ethereum Request for Comments. The Nft Token Standard implements an API, an application programming interface for tokens within smart contracts. It specifies a set of rules for the contract and what the token can do, like its functionality. An Nft token standard is for a token that can have a different value than another token from the same contract, perhaps due to a different age, a different rarity, or a different visual. With an NFT standard, there's many functions and properties part of the standard, which you'll see when we install the standard. You can transfer tokens from one account to another. So doing a trade or a sale, you can get the token balance of an account, you can get who owns a specific token, you can get the total supply of tokens, and more. To read more, go to the Ethereum webpage for tokens. Ethereum.org is a great site for reading more about tokens in general and token standards in general. To build out a token standard, we have to build a smart contract. And in this project, we're using the Solidity programming language to build a smart contract for the Ethereum blockchain. Solidity is a high-level programming language specifically for building smart contracts on the Ethereum. We can compile code for the Ethereum virtual machine. Solidity has a syntax very similar to JavaScript. So if you know JavaScript, you'll easily pick up Solidity. But if you do want to deep dive into Solidity, building more contracts, I do recommend studying Solidity at a further pace. And we do have several courses on Solidity here at Mammoth Interactive. But if you know JavaScript, you can follow along. For more about Solidity, go to the official website for Solidity, its official documentation. You can also go to the GitHub for Solidity, and there you can look at the Issues tab and see what people are commenting. If you ever run into a problem, you can go into Issues and see all the questions that other developers have had to find answers to your potential questions. And that is an introduction to Nft Token Standards. So join me. Coming up next, we're going to hop back into our project and we're going to learn how we can install an Open Zeppelin Nft Token Standard and then use that standard to customize and build our own NFT smart contract. Hello everyone and welcome back to our course. In our previous section, we learned how to build a new Truffle project inside of an NPM project. In this lecture, we are going to learn how we can import a token standard. We're going to be using the Open Zeppelin library, which is the most popular library for an NFT token standard. Because instead of building out the token from scratch, we use a standard which can be accepted across different stores and different decentralized platforms and NFT buying centers. So we're going to be importing the ERC721 token library into our project, which is the token standard for an NFT. So here I am inside of my project folder, and I am going to get started by installing Open Zeppelin. So I use npm install at openzeppelin/contracts-save. So we're going to be doing this via Open Zeppelin. We're going to be copying their current version of the ERC721 token standard. You can also copy it from their website. You don't have to do it via npm. You could just get the class for the token from their website or from GitHub, or just get it from the source files of this section right here in this course. Okay, so we have been able to get the Open Zeppelin contracts. We added one package to the project. We have some vulnerabilities left over, which are fine to just leave as they are for now for this prototype. Okay, one more thing we need to help us use the Open Zeppelin library in our project is the Truffle flattener. And for that, we're going to have to install that library as well with npm install truffle-flattener-save. And the Truffle flattener is going to help us bring that token standard from Open Zeppelin into our NPM project where we'll build our contracts. Okay, now let's create a contracts folder inside of our project, because currently I can list out my contents with ls or dir, and I can see I do have a contracts folder. I can cd into contracts and then list out, and I have migrations.solidity. Okay, into this contracts folder, I want to bring in the ERC721. So here we are going to grab that from Open Zeppelin, which is now inside of our node modules. So let me go back up one parent folder, and we can cd into node_modules, and we can list out all of our node modules included in the project. One of them is Open Zeppelin. If you scroll up to the O's, you will be able to see Open Zeppelin. Let's see, where is it? Okay, we should have, oh, it's at Open Zeppelin. So I'm just going to go up here a little bit higher. Okay, you can see at first we have a bunch of ats, and we have at Open Zeppelin. So we want to use that one. It won't be actually listed without the at. So that is that Open Zeppelin library that we just installed. We can cd into at Open Zeppelin and list out its contents, which are contracts. We can cd into contracts and list out those. Okay, so we have access, build, finance, governance, interfaces. We have meta.tx, JSON package, proxy, security, token, utils. We want to go into token, cd token, because we want to take the Open Zeppelin contract for an NFT, a non-fungible token. So I'm going to cd into token and list out the contents. And you could just do this all via your file explorer or your finder. but I'm doing it via the console. So I can see here I have my ERC1155, ERC20, ERC721, and ERC777. We want ERC721. Okay, that is the one that we want to use. That's actually a folder, so we have to cd into ERC721 and list out its contents. This is the token for an NFT. We have ERC721.sol, IERC721.sol, Solidity files. We have IERC721 receiver.sol. We have extensions, presets, and utils. You can cd into extensions, and you can see there's actually a lot of files. So OpenZeppelin has a lot of different templates and extensions for those templates. Okay, great. So we've located where we have our Solidity file. So what we want to do is take the ERC721.solidity file, and we want to just bring it into our project folder via a flattener. So you could also just do this via manually just copying and pasting it in. We're going to be using the Truffle flattener to do that. Okay, so here I'm going to go back up to my parents. I want to go back into my project folder. Okay, great. So I should be inside of my main project folder. Then I'm going to use npx truffle-flattener. Remember, we just installed the Truffle flattener library, which will help us to get everything we need for the ERC721 Solidity file. I'm going to grab the file from my OpenZeppelin folder. So I have to go into here /node_modules @openzeppelin/contracts/token/ERC721/ERC721.solidity. So we just saw that we had to go all the way there to find the file. So that's what we're doing here. So what we're doing now is going to copy that file and flatten it, meaning taking everything that it depends on and putting it into the file as well. And we're going to bring it into our contracts folder. So we're bringing it into contracts, and we're going to create a new file called ERC721.solidity. Hit enter, and that is going to allow you to copy that file over. You can cd into contracts, and you can list out the contents. You now have ERC721.solidity. Okay, now if you go into your code editor, you'll see ERC721.solidity is inside of contracts. You can open that up and you can take a look through all of the files here. So we have at the top the license. We have then the Solidity versions. We're using 0.8.0 and greater as the compiler version. Then we have an interface IERC165. You may be wondering, what is this? This is actually the interface of the ERC165 standard, and this is likely required for one of the other files that we have, or one of the other interfaces or classes that we have. Okay, then we have again another file here, IERC721, the required interface of an ERC721 compliant contract. Because contracts can rely on interfaces, so you have a bunch of functions here for different functionalities of an NFT, like safe transfer from one address to another address. Next, we have another interface, IERC721 receiver. This is the ERC721 token receiver interface for any contract that wants to support safe transfers from ERC721 asset contracts. We have another one, interface, IERC721 metadata. And you can see they rely on other files like IERC721, which has been brought into this file. Then we have a library address with a bunch of helper functions. We have a contract of context. We have ERC165, the implementation of an interface. And we have the contract for ERC721. And you can see it relies on context, ERC165, IERC721, and IERC721 metadata. And those were all brought into this one file. Okay, then we have a bunch of different functions for the standard. Okay, and that is the end. We have different functions inside of ERC721, like supports interface, get the balance, get the owner, get a name, get a symbol, get a token URI, get or approve a transaction, get approved, set approval, and more. So these are all pre-built functions, pre-built structures and templates for building an NFT, and they are approved and standardized, so that way you can use them on many different websites and platforms wherever you need to use your NFT. Otherwise, your NFT might only be available on one website and then completely break on a different website if you wanted to build your NFT from scratch. So that's why we need a standard. Okay, awesome. Now that we actually have a standard, we're going to use that standard and build on it to actually build our own NFT. So this is just the standard, like the blueprint for an airplane. And now we're going to actually build the custom airplane using the blueprint. So join me in our next lecture. We will build out the contract in Solidity for our NFT. Hello everyone and welcome back to our course. In our previous lecture, we learned how to import in the token standard for an NFT. In this lecture, we're going to build our own smart contract for a custom NFT built on that token standard. So inside of my contracts folder, I'm going to right click and create a new file. I'll call this mytoken.solidity. And you can also, of course, do that via the terminal or command line application. Okay, great. So we have our file. First thing I want to do is specify what version of the Solidity compiler is going to be used. Here I'm going to specify with Pragma, Solidity, and we want to use version 0.8.0. So that means we will have to use that Solidity compiler to compile this version of the contract. And I want to use that because that's what my ERC721 Solidity file is using. So I want to just keep that consistent. If you want to use a different Solidity version, you can. Just note that if you do have a different Solidity version, sometimes the code can change, the language can change. So you do have to be aware of language changes. Typically, you want to just keep consistent with whatever your token standard is. If your ERC721.solidity file is using 0.8.0, use the same for your custom token. Okay, next here, we are going to get this message that it wants us to provide a license. So we can add in a license identifier like MIT to the top of the file as well. That will prevent it from complaining. And by it, I mean my code editor's checking of the code. All right, now we are going to build a new contract with the keyword contract. And then we can give our contract a name like my token. Pay careful attention to this name because that is going to be a name that you use later on. So this you can use as the name of your token, like I'm calling it my token, but you could have it be called Alex token, whatever kind of NFT name you want to give this. So I'm going to just do my token. You don't have to have the word token in it. You could just call this mammoth, right? I'm going to just keep it as general my token. Now we're going to specify that this NFT contract is an ERC721. This means that the parent of my contract is ERC721. That is what I imported in here via ERC721.solidity. Specifically, it refers to, inside of that file, it refers to the very last contract we had here, which was ERC721. So I'm specifying that this contract is the parent of my token, which means that my token can use functions and properties of its parent. Now, for this ERC721, we are going to pass in a name and a symbol, because if you go into the ERC721 contract, you can see it has a constructor for initializing a contract, and the constructor is asking for a name and a symbol for your token. So that's why we have to pass in after ERC721 a name and a symbol here. Okay, for that I'm going to make a couple of constants. I'll make a string constant name, and here you can put in the name of your token, like my token. Typically you want to keep the name consistent with the contract name. We'll have another constant symbol, and here I'm going to use a symbol MTKN for my token without any of the vowels. This is the symbol that will be used on the blockchain for your token. Okay, great. So we have the name and the symbol. Now, you'll get a message that an identifier is not found or not unique, this ERC721. That's because if we want to actually use the ERC721 contract, we have to tell this Solidity file right here, where does that contract come from? So after we specify the Solidity version, we're going to import our ERC721 contract. So where is that contract? It actually is inside of the same folder as mytoken.solidity. They're both inside of this contracts folder. That means to import the standard, I can just go into the parent folder with /. That is referring to the parent folder of the current folder, and then go into ERC721.sol, which is the extension for Solidity. Okay, so there we go. Now we no longer have that message that ERC721 is not found or undefined, because now we've imported in this Solidity file. So any contract you want to use, you have to import where it's from, unless it's actually directly in the same file. Okay, great. So we have been able to set up the contract. All right, now for this token, we can specify more properties, and we can also specify functions to actually be able to perform actions like mint the token. Now we can go into our terminal or command line and go into our project folder. Inside of my project folder here, I want to test if my smart contract can compile with a Solidity compiler. For that, I use npx truffle compile and hit enter, and this will tell me if my smart contract can compile or not in its current state. Okay, and let's take a look at what we have here. Okay, so we can see which contracts we're attempting to compile. We're attempting to compile ERC721.solidity, migrations.solidity, and mytoken.solidity. But we get this parser error that the source file requires a different compiler version, 0.8.0, whereas my current compiler version is 0.5.16. So Truffle is currently using Solidity compiler 0.5.16. We have to update Truffle config to use which Solidity compiler we want to use. So I'm going to go back into my code editor, and I'm going to go into truffle-config. Here I can specify the compiler. So this is the default compiler for my Solidity project. We have version 0.5.6, and then here these are commented out, but we can comment these back in. So if I comment this back in now, my Solidity compiler version is 0.5.1. But I want to change this to 0.8.0 because that is what all of my contracts are using. They are using 0.8.0, and you want to check that all of them are using that one. Migrations is using a range, but as long as your compiler version falls into the range, then you're fine. Okay, so we can see that all of our contracts are using 0.8.0, and now we specified our Truffle compiler version for Solidity in truffle-config. So now if I go back to my terminal and I rerun my command npx truffle compile, I'm going to recompile my contracts. So look at this. Now we have fetched a new compiler version. Okay, here, read these error messages carefully, because it looks like we got a message that we have multiple SPDX license identifiers found in a source file in ERC721.solidity. This can happen when you're using the Truffle flattener. So if you go into ERC721.solidity, the complaint is about this SPDX license identifier appearing multiple times. So just Control F for it, and then just remove it wherever it appears, except for the first time. So this can happen from the Truffle flattener. It can add in these things that Truffle no longer wants. So you're just going to remove all of those. So read whatever messages Truffle gives you. It will tell you what the problem is. So I'm going to only keep the top license identifier. Go back to the terminal. So Truffle has told me that I had that parser error. I fixed that. Now I can try again with npx truffle compile. So be careful and read the messages that you get. It will tell you what you need to change when you're trying to compile your smart contracts. And look at this, now I get the message that we have a successful compilation. We've compiled ERC721.solidity, migrations.solidity, mytoken.solidity, and the artifacts were written to my project folder /build/contracts. It was compiled successfully with my Solidity version. So great, now we fixed all the problems and Truffle has been able to compile our Solidity smart contracts with the specified Solidity compiler. So Truffle is doing the compilation for us, and it actually is going to write artifacts to /build/contracts. So you'll notice inside of your project folder, you now have a folder called build. This appears whenever you compile for the first time, and then whenever you recompile, these will get updated. This is just JSON data about your contracts. So we have a bunch of JSON files now. You can see we have address, context, ERC165, ERC721, and more. These are all compiled because they were all used in our smart contracts. Some of them were just used for myToken. We have mytoken.json, which tells us metadata or JSON data about our contract. It's just a way to JSONify your smart contract. You can see all the properties about that. And this file is huge. Look at this. It has a lot of data. Then the others were generated because we relied on the ERC721 standard, which requires all of these different interfaces and contracts. Okay, so awesome. We've been able to successfully create a new smart contract that is an NFT. We already have that just by creating this child of ERC721 and giving it a name and a symbol. We're using the ERC721 constructor to build out each of our NFTs. So I can see inside of my folder here, inside of the file of ERC721.solidity, I have my contract ERC721, and it has a constructor which we passed to the parent from the child. Amazing. Okay, next up, let's go ahead and build out a new test. I'm going to build a test for my contract. The test will check that the contract can deploy, that it has a name, and that it has a symbol. We want to build out tests where possible because it's very easy for contracts to break, and tests allow you to quickly make sure that none of your project has broken. So join me in our next lecture. We're going to learn how we can build a JavaScript test file to test out our smart contract at any point. And this will come in handy as you have more functionality that you have to make sure doesn't break other functionality. Hello everyone and welcome back to our course. Coming up next, we are going to test our smart contracts. And before we do that, we'll do an introduction to testing smart contracts. We'll be using the library chai.js for testing. Chai is a test-driven development assertion library for Node and the browser. It can be paired with any JavaScript testing framework. We'll also be using chai assertions for promises, known as chai as promised. This extends chai with a language for asserting facts about promises. A promise is an object that may produce a value sometime in the future, either some kind of resolved value or an error message. We'll be using async and await, a special syntax to work with promises in a more easy fashion. With async, you just add the keyword async before a function, and that ensures that the function will always return a promise. Then you can use an await keyword to make JavaScript wait until a certain promise has returned a result. Here's an example of an asynchronous function called foo that returns 1. And because it has the keyword async before its declaration, the function will always return a promise. Let's take a look at a promise that will resolve in 1 second. Here we have an asynchronous function foo that has a promise, a new promise object with a timeout that takes 1,000 milliseconds and will have a message done when it's resolved. We then have a result that uses an await keyword to make sure that The result variable, let result, that is going to wait for the promise to get a value. So only after the 1 second or 1000 milliseconds will the result variable have a value. And that is an introduction to testing smart contracts. So join me coming up in our next lecture. We will use JavaScript and Chai to test our smart contract. Hello everyone and welcome back to our course. In this lecture, we're going to learn how to build a test for our smart contract, because as we build more and more functionality, we want to have tests to make sure that adding a new piece of functionality to the smart contract doesn't break some other aspect of the smart contract. So you want to test where possible. And to get started, we are going to install libraries to help us with testing. I'm inside of my project folder, and I'm going to use npm to install Chai. This is a library for being able to perform assertions. And as well, we're going to install a helper library that is similar to Chai, known as Chai as promised. So let's use npm install Chai as promised. This is for using assertions, but also with being able to use promises and being able to await and use promises very easily instead of having to do it all manually. You can do Npm Audit Fix to attempt to fix any vulnerabilities if those are able to be fixed. Sometimes you cannot fix them just with an Npm Audit Fix. Sometimes they're just part of the Truffle package, like in this case. Okay, let's list out our contents, and Chai as promised are now inside of our Node modules folder. All right, now I want to create a test which we'll put into the test folder, because if you cd into test, you can see there's nothing in there right now. This test folder is where we can put our tests. Now you can put them anywhere you want, but I'm going to put it in there because that's what Truffle kind of expects. Here I'm going to create a new file. For that, you can use Notepad on Windows or Touch on Mac. We're going to create a file called mytoken.test.js because we'll be testing out the file mytoken.solidity. All right, now let's open up our project folder inside of our code editor, and we can see under our test folder, we now have mytoken.test.js. So we're using JavaScript to test our Solidity file. At the top here, we are going to make a constant myToken to refer to our Solidity contract. And this comes from artifacts.require. Just make sure you spell artifacts correctly and use the function require /mytoken.solidity. Now this may appear confusing because mytoken.solidity is not inside of the parent folder of the current folder mytoken.test.js, but this actually comes from our metadata of where our Truffle project expects all of our contracts, which is inside of the contracts folder. Okay, so that's where we're getting our Solidity file. Next, we want to require the Chai library, and we're going to be using as well Chai as promise to be able to use promises inside of our tests. And on top of that, we will specify that we should use those. All right, so we are requiring the Chai library and Chai as promised. Next, we're going to have our contract myToken, and we are going to grab the accounts of the token. Here, I am going to create a variable to represent my contract. And before here, I am going to use an asynchronous callback function, and I am going to grab the contract and await for my token to be deployed. So here we are using my token, and we have the deployed function which comes from the parent of my token. So we are deploying the contract. Next, I'm going to use a describe statement to describe deployment. And I'm going to have an asynchronous callback function. Here I am going to check that the contract deployed successfully. So I open up a new test case with the it keyword. I'll call this that we have our contract deploys. So we can just say deploys, and we have an asynchronous callback with this arrow syntax. And in here we are going to check that the contract deploys. So we can make a constant for the address and use contract.address. Then we can use assert from chai to check that the address is not equal to null. So here I'm going to grab the address and compare it to null. The address should not be null. If the address is null, then that means that the contract was not successfully deployed. So this is our first test here. Okay, we can go into the terminal and we can run this test with going into our project folder. And here we are going to call npx truffle test. So we are running Truffle's test command to execute any of the tests that Truffle finds in the test folder. Here we are using the network test. First, all of our contracts will be compiled. We have nothing to compile because we compiled our contract earlier. Then we have our contract name. We have the before all hook, which is the location of the test. We have 0 tests passing and 1 failing. Okay, then we get the description of the failing test, before all hook in contract my token. We have error, my token has not been deployed to detected network. So in order to actually deploy this contract, we have to set up the network for it to be deployed on. Because yes, we were able to compile the contract. We saw that in previous lectures. But then what about myToken.deployed? In order to deploy a contract, we have to set up a network to deploy it on. So this is the actual network where the NFT will be sent to. So for that, we have to set up the network, and we're going to be using Ganache to do that. So join me coming up in our next lecture. We are going to learn how we can use Ganache to actually deploy the contract and therefore be able to pass this test.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle. And it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.